Imagine absolute silence, not the quiet of an empty room, but the crushing, heavy silence of the Chilean Andes at nearly 9,000 feet above sea level. The air here is so thin, so devoid of moisture, that your lungs have to work harder just to keep you conscious. It is one of the driest places on Earth, a barren, alien landscape that looks more like the surface of Mars than our own planet. And standing here, anchored deep into the bedrock of a mountain called Cerro Pacan, is a giant. For years, it was just a skeleton of steel beams and mirrors, a dormant beast waiting for a heartbeat. Engineers spent a decade polishing its eyes to nanometer precision, cooling its sensors to -100 degrees Celsius, and preparing it for a task that sounds physically impossible. They did not build this machine to take pretty pictures for a desktop wallpaper. They did not build it to look at the same old nebulas we have seen 1,000 times in textbooks. They built it to panic. They built it because something is missing in our understanding of the universe, and we are running out of time to find it. On April 15th, the shutter opened. The largest digital camera ever constructed by human hands, a device the size of a compact car and weighing more than 3 tons, took its first breath of photons. It stared into the southern sky, not blinking, not filtering, and not hesitating. In just 10 hours, it did not just see the universe, it swallowed it whole. This is not a celebration of astronomy. This is the activation of the most advanced early warning system in the history of our species. The Vera Rubin Observatory has just turned on, and you have no idea what it is about to show us. To understand why this moment is terrifying, you have to understand the sheer, overwhelming scale of the machine itself. When you take a picture with a modern smartphone, you are capturing maybe 12 megapixels of data. A high-end professional camera used by a studio photographer might give you 50 megapixels. Even the James Webb Space Telescope, the most famous eye we have had in the sky until now, offers us incredible depth, but it is like looking through a drinking straw. It sees tiny specific patches of the sky in agonizing detail, missing the forest for the trees. The Vera Rubin Observatory is different. It is a monster. Its camera has a resolution of 3,200 million pixels, 3.2 billion pixels. If you wanted to display just one single image from this camera at full resolution, you would need 400 ultra-high definition television screens, all mounted together on a massive wall, all running at once. If you printed that single image out, it would cover an entire basketball court from hoop to hoop without losing a single grain of detail. This is not just big, it is industrial-scale surveillance of the cosmos, and the speed is where the true terror begins. Most telescopes stare at a single object for hours, sometimes days, to gather enough light to see the faint details of the deep past. Vera Rubin is restless. It is a hunter. It takes a massive exposure that covers an area of the sky 40 times wider than the full moon. It holds that gaze for exactly 30 seconds. Then, the entire telescope, tons of precision glass and steel, slews to a new position in just 5 seconds. It stabilizes instantly. It shoots again, another 30 seconds. It does this all night long, every night. Relentlessly. In the first test run alone, in a mere 10 hours of operation, it captured over 10 million galaxies. Read that again in your mind. 10 million individual islands of stars, each containing billions of suns, captured in a single shift. It would take a human astronomer dozens of lifetimes to simply look at every object this machine found in one night. But why do we need this kind of speed? Why are we scanning the entire southern sky every 3 nights? Because the universe is not the static, peaceful painting you think it is. We have been lied to by textbooks that show galaxies as frozen spirals and stars as fixed points of light. The real universe is a chaotic, violent, and rapidly changing war zone. Stars explode without warning, black holes shred their companions, and most importantly for us, rocks move. Thousands of massive asteroids are drifting through the darkness right now, invisible to our current detection systems because they are too faint or move too fast for traditional telescopes to track. Vera Rubin was built to find them. It is creating a living movie of the universe. It compares the image it took tonight with the one it took 3 nights ago. If a star brightens, it knows. If a galaxy warps, it sees it. If a faint dot of light shifts its position by a single pixel while everything else stays still, that is an alert. And that alert could be the difference between a normal Tuesday and the end of civilization. The first official images released on June 23, 2025, are not just photographs, they are data-dense crime scenes. The first target was the Virgo cluster. To the naked eye, or even through a backyard telescope, the Virgo cluster is just a fuzzy patch of light. But under the gaze of Vera Rubin's massive mirror, it transforms into a swarm. The image reveals thousands of galaxies packed together, bound by an immense gravitational grip. But if you look closer, if you zoom in on the spaces between the galaxies, the horror becomes visible. You can see faint ghostly arcs of light. Those are the shredded remains of smaller galaxies that were torn apart. We are looking at a cosmic graveyard. The gravity in this cluster is so intense that it strips stars away from their homes and flings them into the void. This image captures the intracluster medium, a glowing fog of orphaned stars that have been ripped from their parent galaxies, doomed to wander the empty space between the giants forever. Hubble could show us the heart of one of these galaxies. James Webb could show us the chemical makeup of the dust. But only Vera Rubin can show us the violence of the entire neighborhood at once. It shows us the context. It shows us that these galaxies are not isolated. They are interacting, crashing, and devouring each other in a slow-motion ballet of destruction that spans millions of light years. Then, there is the image of the Trifid and Lagoon nebulas. These are stellar nurseries, massive clouds of gas where new stars are being born. In the images, you can see deep reds, which are hydrogen gas glowing from the radiation of newborn suns. You can see dark snake, like lanes of cold dust that block the light, creating shadows that stretch for light years. But the most chilling part of these images is not the nebulas themselves. It is the clarity. This was a test image. The telescope was not even fully calibrated yet. The mirrors were still being aligned. And yet, it produced one of the most detailed wide-field maps of star formation ever seen. It resolved the feedback loops, the cavities carved into the gas by the explosive energy of young stars. It is like watching a bomb go off in slow motion, frozen in time. But amidst all this beauty, the engineers noticed something else, something that was not supposed to be the focus but ended up stealing the show. In the raw data looking past the glowing gas and the distant galaxies, the software started flagging anomalies, tiny, faint dots. They were not stars, they were not noise, they were moving. In the very first set of test images, Vera Rubin accidentally detected thousands of asteroids. Some of them were known main belt asteroids, harmless rocks drifting between Mars and Jupiter, but some of them were new, objects that had never been catalogued, rocks that had been flying through our solar system, perhaps for millions of years, completely unseen by any other telescope on Earth. Vera Rubin saw them in its first attempt. This confirms exactly what the scientists feared and hoped for. The sky is full of invisible objects. We have been living in a crowded room with the lights turned off, assuming we were alone. Now someone has flipped the switch, and for the first time, we can see exactly what is flying toward us. This is why astronomers are calling this the start of a new era. Before Vera Rubin, we were taking snapshots. We were tourists, standing at the edge of the Grand Canyon, taking a photo of a single rock. Now, we are filming the entire canyon in ultra-high resolution, watching every pebble that falls. This observatory will generate 20 terabytes of data every single night. That is enough data to fill your laptop's hard drive a dozen times over, every single night. For 10 years, it will create a database so vast that no human could ever read it. We have to use artificial intelligence just to sift through the flood of information. The algorithms are already running. They are trained to look for transients, things that change. A supernova exploding in a distant galaxy, a gamma ray burst aiming its beam at Earth, an asteroid shifting its trajectory. When the system spots one of these events, it does not wait for a scientist to have a coffee and check their email. It sends out a global alert within 60 seconds. Think about that. 60 seconds after the light hits the mountain in Chile, every telescope on Earth and in space will know about it. Look here. Something is happening right now. We have built a machine that acts as the nervous system of the planet, but detecting asteroids is just the beginning. The true purpose of this machine is far darker. It is hunting for the ghost in the machine, the invisible hand that is stretching our universe apart, because there is something wrong with gravity. And Vera Rubin might be the only thing that can prove it. The story begins with the woman whose name is on the building. In the 1970s, she looked at the universe and realized the math didn't add up. She studied how galaxies rotate, and she found something that shouldn't exist. The stars at the edges of galaxies were moving too fast. By all the laws of physics, they should have been flung out into space, like water spinning off a tire, but they stayed. Something was holding them in, something invisible. Her work provided the first undeniable evidence for what we now call dark matter. She proved that the stuff we can see, the stars, the gas, the planets, you, me, is just the foam on top of the ocean. The ocean is invisible, and for decades we have known it is there, but we have never been able to see it. We have only seen its gravity, its ghostly pull on the things we can see. The observatory named in her honor was built to change that. It is designed to map the invisible. By surveying billions of galaxies, it will look for tiny distortions in their shapes. This effect is called weak gravitational lensing. As the light from a distant galaxy travels to Earth, it passes through clumps of dark matter. The gravity of that invisible matter bends the light, slightly warping the shape of the galaxy behind it. It is like looking at a coin at the bottom of a swimming pool. The water distorts the image. By measuring that distortion across billions of galaxies, Vera Rubin will create a 3D map of the dark matter in our universe. It will show us the scaffolding that holds reality together. But there is a second ghost. Dark energy. The mysterious force that is pushing the universe apart, making it expand faster every second. We don't know what it is. We don't know why it exists. We only know that it makes up nearly 70% of the universe, and here is the scary part. We don't know if it is constant. Some theories suggest that dark energy could get stronger over time. If it does, it won't just push galaxies apart. It will eventually push stars away from planets, then push electrons away from atomic nuclei. It would tear the very fabric of reality apart in an event physicists call the Big Rip. Vera Rubin is the only machine capable of measuring dark energy with enough precision to tell us our fate. It will track the expansion history of the universe over billions of years, looking for signs that this dark force is changing. So when you look at these stunning first images, do not just see the beauty. Do not just see the colourful clouds of the Lagoon Nebula or the sparkling swarm of the Virgo cluster. See them for what they really are. They are the calibration test for a machine built to answer the ultimate question. Will the universe end in fire, ice, or a sudden violent shredding of everything that exists? The camera is open, the data is flowing, and the answers are coming whether we are ready for them or not. But mapping the static shape of the universe is only half the battle. The true terror of the cosmos does not lie in what is sitting still. It lies in what is moving, and more importantly, in what is rushing toward us. Until now, astronomy has been the science of still photography. We take a picture of a galaxy, and 10 years later, we take another picture of the same galaxy, and it looks exactly the same. This has lulled us into a false sense of security. It has made us believe that the night sky is a frozen tapestry, a reliable and unchanging backdrop to our lives. That is a lie. The universe is not a painting, it is a chaotic, exploding, shifting ocean, and we have been looking at it with our eyes closed. The Vera Rubin Observatory is about to open them, and for the first time we are going to see the universe in motion. This is the fifth pillar of the mission, something astronomers call time domain astronomy, but you can think of it as the ultimate security camera for the entire southern hemisphere. Every 3 or 4 nights, the telescope scans the entire visible sky. Over a 10-year period, it will revisit every single patch of the sky around 800 times. This repetition is the key. By stacking these images on top of each other, the computer systems can strip away everything that stays the same, the distant stars, the background galaxies, and leave behind only the things that have changed. It turns the sky into a difference engine. If a star brightness fluctuates by a fraction of a percent, the system sees it. If a quasar flickers as it feeds on gas billions of light years away, the system records it. If a massive star collapses and detonates in a supernova, Vera Rubin will likely catch the very first flash of the explosion, hours or even days before other telescopes would have noticed it by chance. This capability transforms our view of the universe from a museum exhibit into a live broadcast. We are expecting to see millions of transient events, things that flare, fade, or explode without warning. Before this machine, many of these events were missed entirely. We were simply looking in the wrong direction at the wrong time. Now, nothing will escape. The observatory is designed to process these changes in near real time. Within 60 seconds of the shutter closing, the data is analyzed, the change is identified, and an alert is sent out to the global scientific community. Imagine a stream of telegrams from the edge of the universe, arriving constantly, telling us exactly where things are dying. However, the most chilling application of this speed is not about what is happening billions of light years away. It is about what is happening right here, in our own backyard. The solar system is not an empty void with a few planets orbiting politely around the sun. It is a shooting gallery. It is filled with debris left over from the formation of the planets. Rocks ranging from the size of a pebble to the size of a mountain. We call them near-Earth objects, or NEOs. For decades, NASA and other agencies have been hunting for the ones that are large enough to end civilization. The kilometer-wide monsters like the one that killed the dinosaurs. We have found most of those, but we are missing the smaller ones, the city killers. An asteroid that is 140 meters wide would not wipe out the human race, but if it hit a major city, it would obliterate it instantly, killing millions. If it hit the ocean, it would generate tsunamis that could scour coastlines clean. These objects are dark, small, and difficult to spot against the blackness of space. We estimate that there are tens of thousands of them that we have simply never seen. They are flying through the dark, crossing Earth's orbit, and we are blissfully unaware of their existence. Vera Rubin is the hunter that will find them. In its first decade of operation, the observatory is expected to detect millions of asteroids in our solar system. This is not a guess. It is a mathematical certainty based on the telescope's sensitivity. The early tests proved this capability instantly. In those first few hours of commissioning, while the engineers were just trying to focus the camera, the software began flagging thousands of moving sources. Some were known rocks, but many were entirely new discoveries. A software engineer looking at the data noticed a faint dot that did not behave like a star. It moved between exposures, slow but steady. It turned out to be a new asteroid, a rock a few hundred meters wide that had been drifting through our neighborhood for eons, completely unnoticed until that moment. That specific rock might be harmless, but it proves the system works. It proves that there are ghosts drifting through the dark, and now we have the technology to see them. This creates a new kind of planetary defense. Instead of relying on luck or spotting a chemtrail in the sky when it is already too late, we will have a comprehensive census of the solar system. We will know the orbit, the velocity, and the size of millions of objects. We will be able to predict impacts years or decades. But there is a terrifying flip side to this knowledge. Once we turn this machine on fully, we are going to realize just how crowded our orbit really is. We are going to see the sheer volume of traffic that passes within a hair's breadth of our planet every single day. Ignorance was bliss. Vera Rubin brings the anxiety of awareness. It turns the night sky into a radar screen, and that screen is about to light up with thousands of incoming contacts. The sheer volume of data required to do this is almost impossible to comprehend. This is not like downloading a movie. This is a fire hose of information that never stops. Every night, the observatory will capture tens of terabytes of data. Over 10 years, the total archive will exceed half a petabyte. This will be one of the largest scientific datasets in human history. It is so large that no human being can ever look at all of it. We have had to build automated pipelines, complex chains of high-performance computers sitting in Chile and in data centers in the United States, just to handle the flow. The photons hit the camera, are turned into digital signals, travel thousands of kilometers over fiber optic cables, and are processed by algorithms trained to spot anomalies. This brings us to a strange philosophical precipice. We are handing over the observation of our universe to machines. The algorithms will decide what is interesting. The algorithms will tell us what to look at. We are building a digital twin of the sky, a simulation that is updated every night. Students, amateurs, and professional astronomers will all mine this same vast database. A teenager in a basement might find a new comet before a professor at Harvard does. The democratization of the data is beautiful, but the reliance on the machine is absolute. If the algorithm misses something, we miss it. If the code ignores a strange signal because it doesn't fit the training data, that discovery is lost. We are trusting the silicon to tell us what the carbon universe is doing. And the universe is doing something very strange in the deep background. While the asteroid hunters watch the foreground, the cosmologists are using Vera Rubin to look much, much deeper. They are looking back in time to solve the mystery that started with Vera Rubin herself. Dark matter. Remember that we cannot see it. We can only see what it does to light. This effect, weak gravitational lensing, is the most subtle and difficult measurement in all of astronomy. As light from a galaxy billions of light years away travels toward Earth, it passes through the invisible web of dark matter that fills the universe. The gravity of that dark matter tugs on the light, bending it ever so slightly. This doesn't create a funhouse mirror effect that you can see with your eye. It creates a tiny statistical distortion. A galaxy that should look round looks slightly oval. A galaxy that should be vertical is tilted slightly to the left. By measuring the shapes of billions of galaxies, literally billions, Vera Rubin can calculate the average distortion across different parts of the sky. It can reverse engineer the path of the light to tell us exactly where the dark matter is clumping. It is like seeing the wind by watching a field of wheat ripple. You cannot see the air, but you can map its movement by the behavior of the stalks. Vera Rubin is watching the wheat field of the cosmos to find the invisible wind. This map will reveal the growth of cosmic structure. It will tell us how the universe built itself from the Big Bang until today. But it will also test something even more fundamental: dark energy. This is the force that is accelerating the expansion of the universe. By mapping how dark matter has clumped together over billions of years, we can see how strong dark energy has been at different points in history. If dark energy is getting stronger, it means the universe is doomed to be ripped apart. If it is getting weaker, the universe might eventually collapse back in on itself. Vera Rubin is the judge. It is gathering the evidence that will determine the ultimate fate of everything that has ever existed or will ever exist. The first images of the Virgo cluster were just a teaser. They showed us the intra-cluster light, the faint glow of stars ripped from their galaxies. This is a small-scale version of the violence that dark energy inflicts on the universe. In the Virgo cluster, gravity is the monster, shredding galaxies and merging them. But on the cosmic scale, dark energy is the monster, pushing them apart. We are caught in a tug-of-war between these two invisible titans. Dark matter tries to hold the universe together. Dark energy tries to tear it apart. And we, the observers, are stuck in the middle, tiny and fragile, building a glass eye on a mountaintop to see who is winning. The urgency of this mission cannot be overstated. The data suggests that we are living in a unique time in the history of the universe. We are living in the era where we can still see the other galaxies. If dark energy continues to accelerate, eventually the expansion of space will become faster than the speed of light. The other galaxies will disappear from our view forever. They will drift beyond the cosmic horizon, leaving us alone in a dark, empty void. We are racing against the cosmos itself to map it before it runs away from us. Vera Rubin is our attempt to capture the memory of the universe before it is erased. And yet, there is one final piece of this puzzle. One final capability of this machine that makes it truly unique. It is not just looking for dark matter or asteroids. It is charting the history of our own home, the Milky Way. Over the next 10 years, it will record billions of stars in our own galaxy. It will map their positions, their motions, and their brightness. It will uncover faint stellar streams, the ghosts of smaller galaxies that our Milky Way cannibalized billions of years ago. It is like reconstructing a crime scene that is 13 billion years old. We are living inside a predator. Our galaxy grew by eating its neighbors, and Vera Rubin will reveal the bones of its victims hidden in the halo of stars that surrounds us. We are about to see our home for the first time, not as a static disk of stars, but as a dynamic, violent, evolving organism that has consumed others to survive. We are about to see the invisible debris that litters our solar system, the rocks that threaten our future, and we are about to see the invisible scaffolding that holds reality together. The camera is open, the shutter is clicking, the data is already accumulating in the servers. The only question left is, are we ready for what it is going to tell us? Because once you see the invisible, you can never unsee it. The monsters under the bed are real, and we have just turned on the lights. The lights are on, and the clock has started ticking. We are no longer dealing with theoretical capabilities or engineering dreams. We are dealing with a machine that is actively hunting. The timeline for what comes next is already set in stone, and it is moving faster than most people realize. In May of 2026, the observatory will release Data Preview 2, the first full set of reprocessed commissioning data. This is the dress rehearsal, but the real seismic shift happens in January 2027. That is when Data Release 1 opens to the world. For the first time, the global scientific community will get their hands on the first 6 months of true survey observations. From that moment on, the pace accelerates into something resembling madness. The Vera Rubin Observatory will scan the southern sky about 800 times over the next decade, building a complete high-resolution time-lapse map of the universe. This is not just a scientific project, it is the construction of a digital monument. We are building a library of the cosmos that will outlive the people who built it. Astronomers 50 years from now will look at this data to see stars that have since died, or to trace the path of asteroids that have since drifted into the void. We are capturing the present so that the future can judge us. But the most revolutionary aspect of this next phase is who gets to see it. In the past, access to world-class telescopes was a privilege reserved for the elite. You needed a PhD, a research grant, and time on a schedule booked years in advance. Vera Rubin changes the rules. Partnerships with universities, research centers, and citizen science platforms will make much of this data publicly available. Students in high school classrooms, amateur astronomers in their backyards, and coding enthusiasts in basements will be able to mine the same vast database as the professors at top universities. This is the democratization of the apocalypse. It means that the person who spots the next dangerous asteroid, or the first signal of a supernova, or the strange anomaly that defies physics, might not be a government employee. It might be you. We are crowdsourcing the surveillance of the universe. And while that sounds inspiring, it also brings a chaotic unpredictability to the science. We are unleashing millions of human eyes and millions of AI algorithms onto a dataset that contains things we have never seen before. We are bound to find things we cannot explain. We are bound to find glitches in the matrix, artifacts in the data that look like impossible structures, or signals that look like intelligence. The sheer volume of noise will be deafening, but hidden in that noise is the signal that Vera Rubin herself spent her life chasing. This brings us back to the woman who started it all. Vera Rubin did not just discover evidence for dark matter, she championed a specific philosophy of science. She believed that science advances fastest when we observe without bias. She believed we should look everywhere, at everything, and let the universe tell its own story. This observatory is the physical embodiment of that philosophy. Most telescopes are biased. They look where we tell them to look. They look at the things we already know are interesting. Vera Rubin is unbiased. It looks at everything. It doesn't care if a patch of sky looks empty. It collects the photons anyway. It doesn't care if an asteroid seems harmless. It tracks the orbit anyway. This lack of bias is what makes it dangerous to our current understanding of physics. When you look at everything, you inevitably see the things that don't fit. We are currently sitting on a model of the universe called lambda CDM. It says the universe is made of mostly dark energy and dark matter, with a tiny sprinkling of normal matter. It works well on paper, but cracks are appearing. The rate of expansion isn't matching up. The clumpiness of matter isn't quite right. We are building this machine to confirm our theories, but there is a very real possibility that it will destroy them. What if the data from Vera Rubin shows that dark energy isn't a constant force, but something that changes? What if the map of dark matter reveals that gravity doesn't work the way Einstein said it did on massive scales? We are preparing to rewrite the textbooks. The images of the Virgo cluster and the Lagoon Nebula are just the opening shots of a revolution. We are moving from a static understanding of the cosmos to a dynamic one. We used to think of the sky as a painting on the ceiling. Now we know it is a ceiling that is falling down, expanding, and shifting every second. The first images from the Vera Rubin Observatory mark the start of this new era. For the first time, we are not just photographing the universe, we are watching it change in real time. Each night it captures billions of stars, galaxies, and asteroids, turning the sky into a living record of motion and evolution. It is the realization of the vision to measure what others couldn't see and uncover the invisible forces shaping everything. But uncovering the invisible is a phrase that should make you pause. There is a reason we fear the dark. There is a reason our ancestors huddled around fires at night. The dark is where the predators live. In cosmology, the dark is not just empty space. It is the substance that dominates reality. We call it dark matter because we don't have a better name for it. We know it is there because we see the galaxies spinning too fast. We see the light bending around invisible clumps. We see the ghosts, but we have never seen the source. Vera Rubin is drawing a map of these ghosts. It is showing us exactly where they are hiding. It is proving, night after night, that the visible world, the world of light, atoms, stars, and people, is just a thin veneer over a dark, heavy, invisible ocean. We are like sailors who have spent our entire history studying the foam on the waves, thinking that was the whole ocean. Now, with this telescope, we are finally putting on a diving mask and looking beneath the surface. And what we are finding is that the water is deep dark and full of things that do not obey our rules. The observatory will spend the next 10 years staring into this abyss. It will track the distortions of billions of galaxies to outline the shape of the beast. It will tell us how big it is, where it lives, and how it pushes and pulls on our reality. But a map is not an explanation. A map tells you where the monster is. It doesn't tell you what the monster is, and that is the terrifying truth that this telescope leads us to. We are building the most sophisticated eye in human history to look at the universe, and the first thing it tells us is that 95% of everything is missing from our vision. We are surrounded by invisible matter and invisible energy. We are floating in a sea of the unknown. The Vera Rubin Observatory is the ultimate tool for planetary defense. Yes, it will find the asteroids. It will warn us of the rocks that could hit Earth. It will save us from the threats we can touch. But it cannot save us from the existential threat of what we cannot see. It can only show us the evidence. It can only point to the empty space and say, there is something here. It is massive. It is everywhere, and it is controlling the fate of every galaxy in the universe. The telescope has done its job. It has sounded the alarm. It has opened the shutter and shown us the invisible hand of gravity warping the light of the Virgo cluster. Now, the burden of knowledge falls on us. We have to live with the fact that our reality is a minority report. We have to accept that the stars are just the decorations on a much darker structure. The Vera Rubin Observatory has given us the where. It has shown us the location of the invisible scaffolding. But if you want to understand the what, if you want to understand why this invisible substance might not just be matter, but something far more disturbing that challenges the very nature of existence, you need to go deeper. We assume dark matter is just stuff we can't see, but the theories go much darker than that. Some physicists believe it suggests that our entire understanding of gravity is a lie. Others think it could be a shadow universe interacting with ours. The telescope shows us the symptoms, but the disease is much more terrifying. If you want to understand the true nature of this invisible ocean that Vera Rubin is mapping, and why everything you see might be a cosmic lie, you need to watch this video next. It explores the terrifying truth of dark matter that this telescope is just now beginning to reveal. The universe is awake, the camera is rolling, and we are just beginning to see the things that have been hiding in the dark. Until next time, keep looking up